All right, so in class we've been talking all about matter, its different states, how anything that is made of matter has a mass and a volume. And today we're going to kind of further classify matter into different groups based on its properties. So when we do that, all substances can be broken down even further. So matter, we can ask the question, can it be broken down by physical means? Right? So when we ask that question, can it be broken down by physical means, we can either answer no, it cannot, or yes, it definitely can. So when we talk about physical means, I'm kind of talking about like if I have a piece of paper and I can rip it in half, I can physically alter that piece of paper. So that would head towards the yes category, which gives me my next category of mixtures. So matter can be broken down physically, is in the group of mixtures. And then we have a different category over here that no, it cannot be physically broken down. I can't just rip it with my hands or use other physical means to break it apart. And if that's a no, then I'm talking about a pure substance. All right, I'm gonna put some boxes around these two. Those are our vocab words. All right, so pure substances are substances that have a definite physical and chemical composition. And by composition, I mean what it's made of. It's definite. It can't be changed. If it is changed, then it's not the same substance. And that's not what we're talking about over here. That would be over here with mixtures. So pure substances have it's defined. It's the same physical and chemical makeup every time we're looking at it because it's pure. So they're made up of just one either type of particle or combo of particles. One type or one combination of particles. We're going to break that down just a little bit more. And we're going to do that right now. So made of one type or that combination. So if they're made of one type, then we are referring to elements. If they're made of a combination of particles, but one combination, always the same, then we're talking about compounds. All right. So with pure substances, with elements and compounds, physical changes like melting and freezing and cutting, they don't change the identity of that substance. It's still the same substance. I can melt it, I can freeze it, I can melt it and freeze it again, I can cut it in half, I can do whatever, but it's not going to physically change that substance because it's a pure substance. But when it undergoes a chemical change, it may be no longer that same substance. So let's talk a little more about elements. So elements can be classified even further in metals and nonmetals and metalloids. And we're going to talk about that a little later on in the year. But classifying elements help scientists predict the properties of those elements, and that's mainly what we use the periodic table of elements for. So elements themselves are made of one type of atom, right? And they have a definite composition and properties. Right? So each element on the periodic table has its own type of atom. That's what actually makes it an element. Right? So it's made up of a group, one or more of that same type of atom. All right? And some examples of those would be hydrogen, oxygen, right? Anything we have on the periodic table that you could find. Sodium, chlorine, all really awesome elements that we have and we find on our planet made of one atom that can't be physically taken apart and changed into anything else. I can't break down hydrogen and make it something else by a physical means. All right, let's talk about compounds. So compounds we can classify as acidic, or basic, or neutral. Using pH, they can be organic, they can be inorganic, and they can be some of our biochemical compounds you may have learned about in biology, like carbohydrates and lipids, proteins, sugars, lots of really awesome things. But compounds are one or more bonded atoms. All right, so we have one or more atoms that are coming together in a bond, a chemical bond, and it has a definite composition, just like we talked about before. All right, and I like to think of it on this side. It's a definite recipe. So if I was to make a cake, I've got to use the same things each time if I want to make that specific kind of cake. It has a definite composition, a definite recipe in order to make it. And all those things that broken down go into it almost like they were elements, right? We have an egg and we have flour and we have vanilla, all these things that go into our cake, oil, right? But as they are in different amounts, different ratios, right, set ratios, when I put them together and chemically combine them, chemically bond them together, they're going to make me a cake, which is a compound. All right. So just like this example, if I pull these elements over here, which make up compounds, right? If I bring hydrogen and oxygen together in a set ratio of 2 hydrogens to 1 oxygen atom, I'm going to get water. Right? And water is a compound. And water has lots of different properties than, say, hydrogen and oxygen alone over here as elements. They're both gases, and when I bring them together in this ratio, in this definite composition, they're in liquid state, right, at room temperature, and they're non-reactive, and they have lots of other properties. They have different properties. Sorry, I'm running out of room. Than their elemental makeup. All right, so when they combine chemically to make a compound, they actually take on new properties. So we are going to jump over here to mixtures now. Remember, mixtures, we answered yes to this question. It can be broken down by physical means. So a mixture is a combination of 2 or more substances that are combined physically. Okay, but not chemically. They're physically put together. These two chemically, right? I have an atomic structure here, and I have atoms that have been bonded chemically over here. It's nothing physical going on. Here I have physical combinations of these substances put together in physical means. So mixtures are not pure substances, and they do not have definite properties. Right? They can change based on how much I have of, say, this element in there and this compound mixed together in there. That's not defined definite properties or composition. All right? I can have different ratios, different amounts of each. They don't always have to be mixed in the same way, and we can still call it a mixture. So substances within a mixture keep their identities and their individual properties, unlike that compound where they take on brand new properties. So substances keep original properties. All right, and mixtures can be separated by physical changes. Although some may be difficult to separate, we can use magnets and centrifuges and filters and lots of other different methods to separate out a mixture. But it can be done by physical means, and that's what makes it a mixture. So we have two types of mixtures. We have homogeneous or homogeneous mixtures, and then we also have heterogeneous mixtures. If you think back again to life science, right? Homo sapien, we have stems here. So homo means same, and hetero means different. And you may also have heard this in genetics as well, homo and hetero, those stems. So homogeneous mixture, homogeneous mixture has the same composition, right? It's not definite, but it's the same throughout. All right, and here we'd like to think kind of like a glass of lemonade. All right, so if I have a glass of lemonade, I have mixed in here my lemon juice and my water, or my packet of lemonade and lemonade powder and water, and it's thoroughly mixed in. It has that same composition all the way throughout. I don't have all of my packet of mix down here. I've mixed it all the way in, and that's what makes it. That's how I could classify it as homogeneous. A heterogeneous mixture is one that does not have a uniform composition. And what I like to think of here that kind of helps me out is either a bowl of salad where I'll have tomatoes and lettuce over here, and maybe a celery here. I'm not an artist, I'm really sorry. So I have, sorry, I'm just labeling. I might have 3 tomatoes on this side and no tomatoes on this side, and I may have a lot of lettuce, romaine lettuce over here, and a spinach leaf over here. So it's still a salad all the way throughout it, but it may not be the same, may not be uniform all the way through. Whereas over here on this side of my lemonade, I have my lemonade powder and my water mixed together, and over here I have my lemonade powder and my water mixed together. So it's just a little bit different. Another good example of this is a lot of times in metals. So you may have a big, nice serving spoon at home that's metal, but it probably has many different types of metals mixed together, melted down and mixed together, and then formed into that spoon to make it. And that's how we break down and classify matter just a little farther. Physical means, mixtures, and pure substances, all the way down to elements and compounds, and homogeneous and heterogeneous mixtures. We're going to be working on applying this a little more in class and being able to identify these different substances based on their particles, their molecules, and then also just looking at examples in the classroom.